Alright, Math 3 2b.1.2, adding and subtracting rational expressions. Okay, so we're adding and subtracting, and because rationals are fractions, the whole idea is we need that common denom. Okay, the common denom. Okay, so we look at our first one. We have an x and a 5x. How do we get those to be the same? Well, we times the left side by 5. If we do it to the bottom, we have to do it to the top, because technically we're timesing by 1. But 1 we can change into anything over itself, so we kind of use that trick to make it work. So we get 15 over 5x plus 7 over 5x. Now, because we're adding, same denominators, it stays. 15 plus 7 becomes 22, and we can't simplify that at all, so there's our answer. Okay, now looking at 2, you may say, oh, to get this x to be the same, we just subtract by 1. Can't do that. We have to be multiplying. Okay, so most of the time what we end up doing is we just multiply them by each other. Okay, so 11 over x we would times by x minus 1 minus x over x minus 1, which we times by x. Okay, so then I'd leave this 11 times x minus 1 minus x times x is x squared over x times x minus 1. Now, I can go through and multiply these, but I do like to see if things can cancel out. Now, some of you may say this can cancel out, but because of this minus right here, this whole top is a package deal. Okay, we can't do it. So let's distribute the top. We get 11x minus 11 minus x squared over x squared minus x. Okay. Now we can rearrange it to be negative x squared plus 11x minus 11 over x squared minus x. Could we simplify this? Probably not, because I can't think of a number multiplying would be negative 11, adding would be 11. So we're plus we got that negative out there. So we're kind of stuck, so we call that good. Alright? Now, for number 3, same idea. We're going to times this side by x, and this side by 8. So I end up with x times x squared plus 3 over 8x minus 4 times 8 is not 4, 32 over 8x. So I get 8x. Now, I can simplify this to x cubed plus 3x, and then minus 32. And that's how I'm going to have to leave it. X cubed plus 3x minus 32. And there's my answer for number 3. Number 4, we treat the same way. Times this side by x. So x times x is x squared. X times 1 is x over 5x plus times this side by 5. 5 times 1 is 5 over 5x. So we just kind of tack that onto the end there and get x squared plus x plus 5 over 5x. Sometimes you may end up having a like term, and so you could do more with that. Okay, number 5. Now, if it doesn't have a fraction, just make it a fraction. How am I going to get that to be x plus 1? We times the whole thing by x plus 1. Okay, so we get 9x over x plus 1 plus 5 times x is 5x squared plus 5x times 1 is 5x over x plus 1. Then we just basically tack that plus 9 on at the end, extend that, and we call that our answer. Okay. Now, number 6 gets a little bit more crazy. Okay, whenever you're given these guys, let's use the area model, the box method, to simplify that. Factors of negative 2 that would add up to negative 1. How about negative 2 and 1? How about correct? Negative 2 times 1, negative 2x, 1x, x squared. Pull out an x, pull out an x, pull out a negative 2, pull out a positive 1. So we really have 5x times x plus 1 plus 3x plus 1 over x plus 1 times x minus 2. Now what you notice here is this side already has an x plus 1. So to make them even, we just need to times by an x minus 2 to both sides. Okay? So we end up 5x times x, 5x squared minus 10x, plus, let's just add this whole piece on, 3x plus 1, all over that whole thing. X plus 1 times x minus 2. Doesn't matter the order you write it in. It's the same thing. Now we can simplify these, can't we? Negative 10 plus 3 would actually give us, so negative 10x plus 3x would give us negative 7x, and we would call that good. Okay? Because this won't be able to simplify. Alright, now number 7, we've got 3 things, so the first step is let's simplify this guy. Now remember, when we have a number out front, we have to take the first and the last and multiply them together. So that would be negative 18. And then say factors of negative 18 would equal negative 7. How about 2 and 9, with the 9 being negative? So then I build my box. So I've got negative 3 here, 6x squared here, and then 2x and negative 9x. Now we play a little bit of detective. So if I look at this, I need to get a negative 3 out of this negative 9. Can I? Yeah. That would be negative 3 times positive 3 times x. So in this box up here, out of this 6, can I get the other positive 3? Yeah. And what you should see happen is that to get 6, it's 3 times 2, which matches up those two. So we should be able to eliminate everything. So a 3 and an x, a 3 and an x, a 2x, a negative 3, and if there's nothing left, it's always like we can times by 1, so positive 1. So we actually have 8x plus 1 over 3x plus 1 times 2x minus 3, which we should notice are those very same two. So to get them all to match up, this fraction needs to be multiplied by 2x minus 3. So I would do that, and then we'd have minus, parentheses, 4 times 2x, 8x, 4 times negative 3, negative 12, then plus, and this one we multiply by the 3x, plus 1. And since that'll make all 3 of these the same, that's why I'm just rewriting it once, and then doing the minuses and the pluses up here. Just make sure that minus takes into account both of these. So 11x times 3x would be 33x squared. 11x times 1 would be 11x. Okay? Now we clear out some space so that we can simplify our top. So first thing, that minus applies to both. So we really have 8x plus 1 minus 8x plus 12 plus 33x squared plus 11x all over 3x plus 1 times 2x minus 3. So 33x squared goes out front. Okay, negative, positive cancel. 11x plus 1 and a 12 give me 13 over 3x plus 1 times 2x minus 3. And we are done. Now I could try to see if this factors. Easiest way is to graph it and to see what we end up having with our x-intercepts, to see if we could simplify that further. But I'm not worried about that for right now. Okay? Oh, I forgot to state any restrictions on x. Basically, any restrictions on x would be anything that makes x 0. So like this one, 3x minus 1 plus 1, that cannot equal 0. Okay? So if we solved it, it would mean x could not equal negative 1/3. So that would be a restriction. And then we do it for this part too. So that would basically be x couldn't equal 3 over 2. Okay? So those are restrictions. Sorry, didn't catch those. So on all of these, you're just looking like these where it's just multiplying. The only restriction would be 0. This one, the only restriction ended up being x squared minus x. So x cannot equal 1 or 0. Okay? 8x, 5x, x can't equal 0. This one, x plus 1, x cannot equal negative 1. And then this one we add x plus 1 times like x minus 2. So x could not equal negative 1 or positive 2. Okay? Alright, 8, 9, and 10. So, Sam walks 3/8 kilometers to school. After school he walks another x plus 1 over 3 kilometers to get to work. What simplified rational expression describes the total length of both his walks? So, he adds his walks together. So times this side by 8. So 8x plus 8 over 24 plus times this side by 3, 9 over 24. So 9 plus 8 would be 17, so we'd have 8x plus 17 over 24. There we go. 9. So a restriction, there's no restrictions because there's no variable on the bottom. Emma's strawberry farm has a total of 5x hectares of arable land. This past season, Emma planted x squared plus 3 over x plus 7 hectares. That doesn't sound right, but we'll go with it, of strawberries. What simplified rational expression represents the total amount of land in hectares that was not planted last season? So, this minus this, basically. So 5x, let's make it a fraction over 1, minus x squared plus 3 over x plus 7. Okay, so we'd times this side by x plus 7. That would give us 5x squared plus 35x minus x squared plus 3 all over x plus 7. Okay, so that minus would apply to that whole part. So we'd end up with 35x minus x squared and then minus 3. Because that minus includes x squared and 3. So 5x squared minus x squared would be x to the 4th. Crap, not that. 4x squared plus 35x minus 3. Okay, all over x plus 7. Now, then we can't simplify that at all. However, x cannot equal negative 7. If x equaled negative 7, we'd have 0 on the bottom, which we can't have. So there we go. Alright, now the last problem. The width of a rectangle is x plus 2 over 5 centimeters. The rectangle's length is x squared plus 3x plus 2 over x plus 3 centimeters. What expression represents the perimeter of this rectangle? So basically this plus this twice, right? So that would be 2x plus 4 over 5. Okay, then this twice, which would be plus 2x squared plus 6x plus 4. I doubled everything over x plus 3 because that's what would happen if we added them. Okay, so now this we need to times by x plus 3 on both sides, or on top and bottom, this by 5. So our denominator is going to be 5x plus 15. Okay, so we get 2x squared, and I'm out of space, aren't I? Let's go up here. So 2x squared, x times 4 plus 4x, plus 3 times 2x, 6x, plus 3 times 4, 12. Simplified, 2x squared plus 10x plus 12, all over 5x plus 15. Okay. Then we're adding to that this side, so that would be 10x squared plus 30x plus 20, all over 5x plus 15. Combine like terms. 12x squared, 40x plus 32, all over 5x plus 15. Now, could we try to simplify this one? Yeah, we probably could. there's probably something we could take away. So I suppose I should show you one of those, right? So, first thing I could do, that's like 4 times 3, 4 times 10, 4 times 8. So it'd be 4 times 3x squared plus 10x plus 8 over 5 and 5, 5 times x plus 3. 3 times 8 would give us 24. Are there factors of 24? So we'll need to do the box method, area model. Factors of 24 that add up to 10. 6 and 4. So 6x, 4x, 8, and 3x squared. So we know we're going to pull out an x and an x. This would be like 2 times 3. So we pull out a 3x here. So this would just be an x. 8 is like 4 times 2, so plus 2, and then plus 4. So we'd end up with 4 times 3x plus 4 times x plus 2 over 5 times x plus 3. Now, it just so happens that we can't pull anything out. So we could have left it like that, with a restriction of -3. X cannot equal -3. Alright, there we go, guys.